Let's talk about earthquakes. We all think we know what causes them, right? But what if I told you the real story is way more complex, more mysterious, and sometimes, honestly, a lot more surprising than you'd ever imagine? I mean, you probably learned the textbook version back in school, right? Giant plates of rock grinding against each other. And look, you're not wrong, but that's just chapter 1. The thing is, earthquakes are popping up in really strange places, at depths that should be totally impossible. And for reasons that, get this, sometimes have less to do with deep geology and more to do with, well, us. So let's dig in and find out what really makes the ground shake. Okay, so first things first, we've got to start with the main suspect, the big engine that drives almost all the seismic activity on our planet. And that, of course, is plate tectonics. So the ground right under your feet, it's not one solid piece, not at all. Think of it more like a giant cracked eggshell. It's broken up into about 15 massive plates, and they're all floating around, jostling for position. And they're moving at about the same speed your fingernails grow. Kind of wild, right? But what's actually pushing them? Well, it all comes down to heat from the Earth's core. I want you to picture the mantle. That's the huge layer of rock right under the crust, like a giant pot of water on a stove, but in super, super slow motion. Hot rock rises up, spreads out, cools off, and then sinks back down. This creates these massive, slow-moving currents that just drag the continents along for the ride. And because they're always moving, these plates are constantly bumping into each other at their edges, what we call boundaries. And they do it in one of 3 main ways. They either pull apart, they smash right into each other, or they just slide past one another. It's these boundaries, that's where all the action is. But here's the really crucial part. The energy released isn't slow and steady, it's sudden. As the plates are trying to move, the rock along a fault line gets stuck. It gets locked up by friction. But the plates keep pushing, so the rock starts to bend and deform, storing up energy just like a stretched rubber band. We're talking years, decades, sometimes even centuries of this energy building up until finally the stress is just too much. The fault gives way, snap. All that stored up energy is released in a matter of seconds, sending those powerful seismic waves out in every direction. And that is your earthquake. Okay, that's the classic story. But here's where it starts to get weird. If all the action is supposed to be at the plate boundaries, then how do you explain a massive earthquake striking thousands of miles away from any of them? I mean, this is a huge puzzle for geologists. You've got places like the middle of the United States or even Botswana, places that are supposed to be rock-solid, stable parts of a continent, and yet they've been hit by some pretty major earthquakes. So what gives? How is that even possible when they're nowhere near a plate boundary? Well, the answer seems to be that the planet has a very, very long memory. You see, these continental plates, they're not perfect. They're riddles with ancient scars. Think of them like old, healed-over wounds. These are prehistoric fault lines and failed rifts from hundreds of millions of years ago. And even though they're not active boundaries anymore, they're still weak spots. The constant stress from all that motion at the real plate edges can travel through the plate and find these old weaknesses and wake them up. And what's absolutely fascinating is that it doesn't always take a huge push to set these old faults off. Sometimes they can be nudged over the edge by surprisingly subtle things. For example, when the massive ice sheets from the last ice age melted, that huge weight was lifted off the crust, causing it to bounce back up. Or, the simple erosion of a mountain range over millennia. Even large-scale human activities like quarrying can shift the stress just enough to trigger a quake on a fault that's been dormant for eons. All right, so we've got quakes happening in unexpected places. That's puzzle number 1. But what about quakes happening at downright impossible depths? For our next mystery, we have to travel hundreds of kilometers straight down, deep into the Earth's mantle. This one is a real head-scratcher. These so-called deep focus earthquakes are happening in a part of the planet where the heat and pressure are so immense, so extreme, that rock shouldn't be able to break. It should just flow, like warm putty or thick honey. So how in the world can it possibly snap and cause an earthquake? And that's really the core of the problem here. The shallow quakes we talked about, they make total sense. You've got cold, brittle rock, and it breaks. Simple. But these deep quakes, they just defy that basic physics. Down there, the conditions are just all wrong for a classic snapping kind of fracture. So scientists have come up with some pretty wild theories to explain this. One idea is called dehydration embrittlement. Basically, as a tectonic plate dives down into the mantle, The water trapped inside its minerals gets cooked out, and this high-pressure steam literally fractures the rock from the inside out. Another cool theory is that certain minerals, like olivine, get squeezed so hard and so fast that they suddenly collapse into a denser structure. It's like the crystal itself fails, creating a fault zone almost instantly. This is still a hot topic of research, and the real answer is probably a mix of these amazing processes. So, just to recap, we've got earthquakes in weird places and earthquakes at impossible depths. But the final twist in this story, this one brings the cause much, much closer to home. What if the culprit isn't a natural geological force at all? What if it's us? Just take a look at this. This graph says it all. For decades, the central part of the US had a really low, predictable number of earthquakes. And then, right around 2009, the numbers just go through the roof. It's an explosion of seismic activity. And this dramatic spike lines up almost perfectly with a huge boom in one specific industrial practice, injecting massive amounts of wastewater from oil and gas operations deep underground. And how it works is actually pretty simple to understand. When you pump millions and millions of gallons of fluid deep underground, it fills up all the tiny, microscopic spaces inside the rock. This jacks up what scientists call pore pressure. And what that does is it basically pushes the two sides of a fault apart, reducing the friction that was holding it locked in place. In a way, you're lubricating these ancient, hidden faults, making it way easier for them to slip and cause an earthquake in places that should be geologically quiet. So far, we've kind of been treating earthquakes as this destructive, mysterious force. But for this last part, I want to flip the script, because in some cases, earthquakes aren't a sign of impending disaster at all. In fact, they're more like a vital sign. You see, for a scientist studying a volcano, a constant stream of little earthquakes, that's the language of the mountain. It's how they listen in to what's going on deep underground. It lets them track magma as it starts to move and push its way up to the surface. And every different type of tremor tells a completely different part of the story. You have what are called volcano-tectonic quakes. That's literally the sound of rock cracking and breaking as magma shoulders its way up. Then you have long-period events, which are more like a deep hum. That's the sound of cracks and conduits resonating as magma and gas slosh through them. And then there's tremor, a continuous, non-stop vibration, like a steady heartbeat, that tells scientists magma is flowing consistently. By piecing all these clues together, scientists can get a pretty good idea of when an eruption might be coming. So, as you can see, what really causes an earthquake isn't just one simple thing. It's this incredible, complex story. It's a mix of immense tectonic forces, the planet's ancient memory, bizarre deep Earth physics, and now a very clear human fingerprint. And that leaves us with a pretty heavy question to think about, doesn't it? If we now know we can wake up dormant faults and cause earthquakes, what other fundamental planetary processes are our actions influencing without us even realizing it?